Pull up these notes from yesterday or 2 days ago. Remember the stuff from yesterday? Think you got it? Or Tuesday? Good handle on it? Okay, good. The next step then is to go the other way. So if I give you a compound, can you come up with a name? We're going to look at a couple different categories of this, and we're pretty much going to work on this all day today. So let's see how we can do. We're going to first look at two different categories of names. Now, we've already looked at these names, because we did it on Tuesday, and we went the other way. We took the names and we put them in compounds. So now we have to talk about what are the two categories so that you can figure out the names from the compounds. So let's look at that together. Here. Okay. Here's the two categories. One, there's a fixed charge on the metal, and we'll talk about what that means in a second. And two, variable charge on the metal. All right, so what do you think that means based on what we did on Tuesday? What two categories are we referring to here? Electrons, yeah. Right. So we're looking at, remember last time we looked at kind of two types of names. One where we knew the charge because we could look it up on the periodic table or we could use the valence electrons to figure it out. And then at the end of class, we looked at a different kind of metal where you can't do that. These transition metals where we said, we don't know the charge of that. So we have to be told it. With naming, it's the same. Two categories. So the fixed charge on metal means that we know the charge. Just by looking at what metal it is, we know what the charge is, or we can figure it out. Maybe we don't know it, but we can figure it out. And if we look at the periodic table, we can get that. So let's draw a little periodic table here. Where are the ones that we know the charge? Well, they're over here, right? Those first two columns, we know those charges. And that's actually pretty much it for the metals, because remember, there's a line and everything over to the left from the right on the line is the non-metal. So the only real other one that we know for sure is aluminum right here. Put that one in there because we know that's plus, that one fits also, that's +3. All that stuff in the middle, we don't know the charge. Now, this isn't entirely true. It's a little bit of an oversimplification. So just for this diagram, I'm going to give you a couple more, but you don't have to know them. So I'm just going to kind of make a dotted line. Here are the ones that we know the charge of. We know group 1A is always +1. Group 2A, the metals are always +2. Aluminum is always +3 or 3+. And then there's actually 2 more. Well, it's 3 more. We'll look at a couple of them. Zinc is always 2+. Silver is always 1+. Cadmium is 2+. I'm only going to ask you to remember these 3. So know that the group 1As are all +1, the group 2As are all +2, and aluminum is +3. Let's kind of give ourselves a little separation here. And we're just going to look at this one category for now. These are the easiest ones to name. Once you've identified that an ionic compound is in this category, all you need to do is stick the names together as we did, as like the compounds we looked at before. So that gives you things like this. Well, here, let me show you what the name is in general. That might be how we think about the name. You just say what the metal is, and then you say the non-metal, but you cut the end off and put IDE. IDE. If you forget, think of some of the really most common ones in this category, like NaCl. What's the name of that? Sodium chloride. Think about where that comes from. Sodium chloride. Nothing fancy there. We just say sodium, and then we say the nonmetal, which is chlorine, but instead of "ene," we say "ide" at the end. They all get "ide" at the end. Okay, what about this one?
Bromide?
Yep, that's it. Magnesium bromide.
Aluminum oxide.
Yeah. Aluminum oxide. We should also mention aluminum is sometimes known as aluminium. That's a fine name for it. It's a US, not US thing. Usually in Europe, it's aluminium, and here it's aluminum. Whatever you like is fine. It's the same thing. Notice what we don't have in the name here, and that is numbers. We've got NaCl, MgBr2, Al2O3. Those subscript numbers don't come up in the name. They're nowhere in the name. We don't say dialuminum trioxide or something like that. That's a different kind of a compound that we're going to talk about a little bit later. But for the official naming rules of these things, we just leave it as we see it right here. All right, so you think you can do this one? Everybody feels good about this? Okay, and let's look at the next category. When there is a variable charge on the metal, what do we do in this case? So that's everything else in the periodic table. Where there are different possible charges. So it could be +1 or +2 or +3 or +4. We don't know. There's different ones. We talked about those at the end of class yesterday. All right, let's look at our periodic table one more time. Where are the metals that have different possible charges? Pretty much everything else. So all this middle stuff, the transition metals. and even kind of getting into down here, just before they become nonmetals. This would also include the lanthanides and actinides, the things down here. Those have different possible charges for the most part. So remember last time when we looked at naming these things, we put in this, or we had this Roman numeral number to tell us what the charge was. That's what we're going to have to put in the name now. The tricky part is we have to find that number. So let's look at how we find that number. We kind of do the opposite thing of what we did last time. So the name is going to be metal with that number in parentheses, whatever it is. We'll just put 2 with nonmetal ide. And that 2 part is what's important now that we didn't have before. So we have to make sure that's in there, or else we don't know what kind of charge we're talking about. So let's look at, okay, I'll keep the color, try to keep the colors. Cu2O. First, the thing to do first is always just to get the names. Write that part first. So Cu is copper. Yep, you don't have to know that, by the way, but you could look it up on your periodic table. That's copper. And then oxygen is going to turn into oxide. Yep. So we can write that first. We're going to leave a little room because we know that we need something in parentheses here to tell us the charge on copper. So how do we figure out the charge on copper?
We have one oxygen and 2 coppers.
Yeah, we use the other things in the formula that we know about. What I mean by that is we said that we don't know what charge copper is right here. We don't know. Do we know what the charge on oxygen is? We do, because oxygen always has the same charge. What is it? -2. So we can say, okay, we know, we can take it apart over here and say we know that oxygen is -2. And we know that there are 2 coppers because of the little 2 below the name. So what does the charge of each copper have to be so that the whole compound is neutral overall?
Each copper should have 1 plus.
Yeah, each copper needs to be +1. And that way we have overall 2 plus and 2 minus. So then to finish our name, we're going to put a 1 in the parentheses. And this is copper 1 oxide. Try to avoid the most common mistake, which is a lot of people see this 2, and so they want to put the 2 in there. That's not correct. This is the charge, so you have to figure out what the charge is and then put it in there. Okay, let's try a couple. Whoa. Is it doing that? Oh. Okay, maybe we're not going to be writing right now. Not save file. Whoa. Maybe it just doesn't like that one spot. There we go. Okay. So we're going to do FeCl3. Almost did that in a second. And then we will also look at Tl2s. Okay. So see if you can come up with a name for each of those. Use your periodic table to look up the words and see if you can come up with a name. All right, guys, names. What did you come up with for FeCl3? So it's iron chloride. And then what do we put in the parentheses? 3, right? It looks like 2. Let me try it. 1, 2, 3. Iron 3 chloride. So we take we take the thing apart. We find that there are 3 Cl minuses. Add those all up and you get -3. That means we need the iron to be +3 to compensate for that. Okay. And what about Tl2s? Close. It's Tl, not Ti. Yeah. Thallium. That's number 81, right between lead and mercury. It's very poisonous, nasty element. So yes, this will be thallium sulfide, but what is the number that we put in there? 1, right? Because the sulfide we know is -2, and that means we need we need +1 on each thallium because there's 2 thallium ions there. Okay. Another common mistake that I see in these problems is confusing the 2 categories. Make sure that when you're naming one of these compounds, you always put it in one of the categories first. So if we had sodium chloride, and you wrote it as sodium 1 chloride, with a 1 in parentheses, that's not correct. We need to use the correct name. So we first put it into categories based on whether that metal has a variable charge or not. And then we put the name, put the number or not, and we do the name. Sound good? All right. We're going to put this all together at the end of class today once we've gone through all the different categories. And I'm not going to tell you what category something is in, and you'll have to categorize it and then name it. And that's really the goal of all of this. Okay. The last part of ionic naming deals with something called a broken computer. We're just going to leave that there. Polyatomic, ions. Polyatomic ions are ions that have more than one atom in them. Poly means more than one, atomic means atom. All of these previous ones that we've talked about have been monoatomic ions, meaning each ion only has one atom. Either it's the metal or it's the nonmetal. But a lot of ions actually have multiple multiple atoms within them. So we're going to look at some of these, such as NO3 minus. This ion is called nitrate. So this is an ion that is made up of nitrogen and oxygen. But we can't say oxygen is -2, nitrogen is -3. That doesn't make sense in this context. The whole thing together is -1. So when it makes an ionic compound, it stays together as an ion. And it gives us compounds like this. NO3. Say that again. Okay, I don't know what's happening here. I don't know which program is malfunctioning at the moment. Let me try this thing. Like a calibration thing. Oh, yep, I think that we know it's malfunctioning. The screen. No, that didn't help. The other thing I can do is make sure this thing's plugged in. Just find a different spot. All right, you get the idea. NaNO3 is called sodium nitrate. There, fixed it. At least I can type. So that's sodium nitrate. And we use that whole ion name for that. Okay, there's bad news and good news about these ions. The bad news is there's no way to figure out what their charge is or what their formula is. You can't look at the periodic table and say, oh yeah, that one's here, so it must be -1. You have to just remember it. So it's some stuff to memorize. The good news is there's not that many that you need to memorize. So if you head over to Blackboard, we'll do that together right now. You go to course materials. This is ionic and molecular compounds. And here's our objectives that we can study. When we talk about polyatomic ions, that's number 7 here. So I'm going to copy this into the notes. There is a list of a few of the most common ones that you need to know. Over here. Delete this thing. Give the name, formula, and electrical charge of the following polyatomic ions: ammonium ion, carbonate ion, bicarbonate ion, hydroxide, nitrate, phosphate, and sulfate. So that's 1, 2, 3, 4, 5, 6, 7. So you got to know 7 of them. You got to know the name, the formula, and the charge. And then we'll use those to build the compounds. So let's put them down here so we have a chart. We already did nitrate. Let's go to ammonium. Ammonium is NH4 plus. It's the only cation that we have to remember. Carbonate is CO3 minus 2. Bicarbonate, sometimes known as hydrogen carbonate, is like carbonate but with a hydrogen, and it's minus 1. Hydroxide is OH minus 1. Phosphate is the highest charged one. That's PO4 3 minus. And sulfate is SO4 2 minus. So there you go, 7 of them. Make flashcards, put them in your phone, make a little list, whatever you want. Some people like to group them by charge. So they think of all the ones that are minus 1, and then the ones that are minus 2, and the one that's minus 3, and the one that's plus 1. Other people just like to keep a list around on their folder or something. But please make sure that you remember these. There's no other fancy tricks I can tell you. You just have to remember them. And then we'll use them in naming compounds. And they go by the same rules as everything else we've just done. So while we're looking at this list, let me delete this crazy thing here. Let's try to name some while we have this in front of us. And go backwards and also write some formulas from the names. So let's see if we can name Looks like it's working for the moment. So I'll try to put this back on there. I think I did tweak out everything. All right, so that was Oh, there it goes again. Calcium hydroxide, K2CO3. NH4Cl. Cobalt 3 phosphate. Go ahead and look up the names on the periodic table or the ions on this list if you need to. I'll try to run this thing again. All right, let's look at these. What'd you get for calcium hydroxide?
Potassium carbonate.
No, this one. Oh, yeah, okay, we can start there. That's fine. Potassium carbonate? Yeah, sounds good. Afraid to write, it's just going to go crazy. Potassium carbonate. Right. So we recognize that K is one of those metals that we know the charge of. It's always +1. That means we don't need parentheses, and we can just call it potassium carbonate. Now, the problem with these is if you didn't know that CO3 was carbonate, then you wouldn't get the name right. And so that's why I'm really emphasizing that here. This is stuff that's going to come up for the whole semester. And if you don't learn these ions, they're just going to keep coming up, and you're going to keep missing the names over and over again. So please take the time now to learn those. All right, what about NH4Cl? Right, we recognize that in this case there isn't a metal because the positive ion, the cation, is ammonium, NH4+, but we see that one, we know it from our list, and then we know that Cl is chloride. So we call this one ammonium chloride. Good. All right, now going to the formulas. Calcium hydroxide. How do you write a formula for that? Right. So the way to do this is just as we did on Tuesday, but this time with the polyatomic ions. So we have to figure out what the ions are, how many of each we need, and then stick them together so that it's overall no charge, overall neutral. Calcium is Ca, and what's the charge? +2. +2. And hydroxide is OH -1. So how do we bring those in balance? Right, we need one more OH. Now that works. So let's write that together. We have to be a little bit careful here. We can't just write CaOH and put a little 2 like that. That doesn't work. What's wrong with that? Right, because that makes it look like just the H gets 2. And we need the whole thing to be 2. So the way we solve that problem is we put parentheses around the ion and put the 2 like that. And that means 2 of those whole things. That way our overall charge is neutral. Calcium, we have the 2+, and each OH is -1, so that's -2 total. +2 minus 2 cancels out. All right, same thing then with our final one, cobalt-3 phosphate. In this case, the charge is given as +3. So we write that one down first. Cobalt +3 is the ion. And what's phosphate? Yeah, PO4 3 minus or -3. So are those matched, or we have to adjust the ratios? That's matched, so it's just COPO4. I've asked this exact name on an exam before, and usually at least a few people say CO and then a little 3 PO4 because of that 3. And that's a common mistake, and please don't make it. That 3 refers to the charge on cobalt, not the number that goes down here. You have to write the charges down first and then see how many of each you need to get them matched up. All right, we're going to look at one last category of names, and then we'll put it all together and just try names in all categories without telling you what category it's in. If this thing works. So the last category is molecular compounds. Molecular compounds, we're going to get in the next chapter, a couple chapters, we're going to talk about bonds and how these compounds fit together. Molecular compounds, for our purposes right now, we can just think of as no working computer. We can think of it as no metals. Right. All the ionic compounds had a metal and a nonmetal, with the exception of ammonium compounds. Molecular compounds are the compounds that have no metals. So we're talking about things like, and you know some of these, things like CO2. Carbon and oxygen are both nonmetals. So this is not an ionic compound, this is a molecular compound. But what was the name of this one? Anybody know this one? Carbon, yeah, right, carbon dioxide. Notice how that name is different from the names we've just been talking about in that little prefix before oxide. What about this one? CO. You know that one? If it's just CO, it's carbon something. This is a poisonous gas. Yeah, this is carbon monoxide. And so you can see here why we need a different kind of a naming system, because we could have CO, we can have CO2, some other compounds like nitrogen, oxygen, you can have NO, N2O, NO2, N2O5, there's a whole bunch of them. So the other names that we've used don't really work. That's why for molecular compounds, we simply specify how many of each there is. We don't worry about charges or anything like that. We just say how many of this atom are there, how many of this atom are there. And we use some prefixes. Here, let me. little bigger so you can see it better. I don't know if this is any better. So here are the prefixes that we're going to use. I'm only typing because the pen, is not working right. 1 we call mono. 2 is di. 3 tri. 4 tetra. 5 penta. 6 hexa. And we're not usually going to go higher than that. Not that they don't exist, but we won't worry about it. So the name becomes just prefix before the first one, prefix before the second one. The exception is mono. That prefix is only, or is, we'll say, oops, not only, but not used on the first atom. So you'll notice carbon dioxide, there's 1 carbon, there's 2 oxygens. It should really be, based on these rules, monocarbon dioxide, but we leave that mono off when it's on the first one. We only use it when it's on the second. All right, what about N2O? How'd you name that one? Yeah, exactly. Dinitrogen monoxide. 2 nitrogens, 1 oxygen, dinitrogen monoxide. Once you get used to it, this is actually the easiest one because you don't have to look at the charges. You don't have to think about, is it fixed charge or variable charge, or is it this type or that type? You just say, oh, okay, 2 N's, dinitrogen. 1 O, monoxide. Pretty straightforward. What about this one? P2O5.
The phosphorus,
Mm-hmm.
pentaxide.
Yep. Diphosphorus pentoxide. Notice also here, when there's 2 vowels together, like pentaoxide, we leave off the end of this one for the A's. If you don't do that, that's fine. It doesn't really matter. You can just leave it on there. But that is usually how it's said. So if you put on an exam diphosphorus pentaoxide, I would still give you all the points. But if you looked it up online, you'd see that it's pentoxide. But they leave off that A. So that's all the names. All right, so now we're going to put it all together. I'm going to give you a list of formulas and names, and you have to write names from the formulas or formulas from the names. Sound good? For today, you can use all your resources, all your notes and everything from before. Ultimately, we want to be able to do this using only a periodic table as a reference. All right, let's try it. Let's see if my pen holds out to actually do these or if I have to type it all. All right, here's 6 to get you started.
That is 3 plus. C minus 2, 3. And then it's 15. Oh, calcium is for this one. Right, check if I wrote. Now, carbonate is capital C, capital O, and 3. It's one of these. One of these. Chemicals like this, carbon dioxide.
When you think you've got a couple, or if you're stuck, turn around to the people around you and see what they got. See if you can work it out together. Or if you see that different people have different things, talk about that. Questions or comments? Are you stuck on something? Okay. Okay. Go to the bigger page. This one. Check. Yeah. Okay. Careful. This is a right.
But we have parentheses, that's okay?
No, the parentheses are on the outside of the whole thing. See that? Those stay together. All right, we've got about 15 minutes left, so I want to go through these and make sure you stop me if you have questions or if you want to know how I did something that isn't totally clear. What do you think was the easiest of all of these?
SO3 and KO2.
Okay, we'll start there. SO3, which category do we put that in? Yeah. It's always important, and I noticed this looking around at some of the things that I saw, always put it in the category first, because that changes how it has to be named. And until you're really comfortable with this, you want to do that. That was a particular issue on this first one, this PD, so we'll get to that in a second. So this category is covalent, which means we're going to use the mono, di, tri kind of name for it. Once we've got it in that category, we know that it's easy to name. We just say how many of each of the things there are. There's one sulfur, so we don't say anything for that. And then the oxygen becomes trioxide. That's it. Okay, let's look at the one next to it, K2O. Where do we put that one? What category does that go in? The categories are ionic with a fixed charge, ionic with a variable charge, or covalent. So this is fixed charge because potassium is over on the left. Oh, this thing's broken again. I will just use the text. So category is going to be ionic fixed charge. And then our name will be without any numbers, parentheses, it's just metal, and then non-metal with ide. So that's potassium oxide. We leave it at that. All right, let's jump over to the one on the far left then, because I know that one gave everybody some trouble. Which category does this one go in? Right, PD, palladium, is in the middle, number 46. So that's going to be a variable charge. Meaning we don't know what the charge is. So we have to look at the other ion to figure out its charge. We also see this as a polyatomic ion because the anion is NO3. And which ion is that? That's nitrate. So we want to list those ions, kind of break it apart. NO3 minus, and we've got 2 of those because there's a little 2 outside of the parentheses. So that tells us that our palladium has to have what charge to balance out those 2 minus 1s? Yeah, 2 positives. Now we've got all that set up, we can write our name, which is going to be palladium 2 for the +2 charge, nitrate. Some of the things I saw were people getting that this is palladium and this is nitrate, but leaving off the 2. And that's why it's so important to categorize it first, to notice that it's in the variable charge group, and therefore it needs that 2. Okay, let's make some formulas from names. Rubidium fluoride. Now when we're making the formula from the name, we don't need to know what category it is. This is what we did on Tuesday before we knew anything about categories. We just need to make sure that we stick the things together properly in the right amounts. So in this case, we have rubidium, which is Rb plus 1 from group 1A, and fluoride, which is F minus 1 from group 7A. Plus 1, minus 1, we don't need to adjust the numbers at all. So the formula is going to be RBF. That one? Good. Okay, iron 3 sulfate. Sorry for the scribbles there. Once again, we don't need to know anything. Everything is given here, but we should write down our ions to make sure that our ratios are balanced properly. So iron 3 means that our cation will be iron plus 3, 3 plus. And the sulfate ion is always SO4 minus 2. And again, that's just something that you have to know. You have to remember that sulfate is always SO4 minus 2. Once you know those, we can try to match up the charges. This was a problem that we ran into on Tuesday also. We can't just change one of them because if you double the 3 plus, you get 6 plus and 2 minus. If you double the 2 minus, you get 4 plus, or 4 minus and 3 plus, so they never get equal. So what do we have to do to fix that? Yeah, we need a common multiple where we change the numbers of each of them. So we're going to take 2 of the 3 plus and 3 of the 2 plus. That will give 6 plus overall. And 6 minus overall. So we add all those charges together. 3 plus 3 minus 2 minus 2 minus 2 is 0. And then we can write the formula. So that will be 2 irons and 3 sulfates. All right. And last, we're going to get this name for Na3P. We should put it in its category then. What category is this? Ionic, because of metal. And fixed charge, right? Because the sodium always is +1. Okay, and we can write the name. Sodium. And what's P? Yeah. Remember, P is phosphorus, and when we change it into an ion, we make that, whoops, phosphide. We add that "ide." I saw a few papers where people wrote phosphate. That's a easy mistake to mix those two up. Remember that phosphate is a polyatomic, is one of these. So phosphate means PO4 3 minus. Phosphide means P 3 minus. Very, very different ions, very different behavior, very different things. All right, think you can do this eventually? Eventually with practice? Yeah. Let's have a quiz on the ion stuff or on the atom stuff, like number of particles, and also on the names next Thursday, a week from today. So you have a week. And the lab on Wednesday is going to deal with some of this as well, where you're going to have some practice writing compounds and trying to figure out what the compounds are. All right, should we do a couple more before we leave? Yeah? All right, let's do a couple more. We got about a couple minutes here. Oh wait, we already did this one, didn't we? No. All right, one to give the formula and one to give a name. All right, you got some names? Who feels good about these two? I feel like you probably got it. Maybe. Okay, that's good. Let's see. So calcium phosphate. This is going to be a polyatomic ion phosphate. So that's PO4 3- and calcium 2+. So how do we put those two together? Right. So we need three of these, and 2 of these to make 6+, 6-, make that balance. So that's Ca3 PO4 2. And then CuOH2. We should categorize this first. Which category does this go in? Yes. So this is ionic with variable charge because of the copper. So Cu is copper. Close. It's copper and it's hydroxide. We just need to figure out the charge. So let's look at the ions. Hydroxide is what charge? -1. And there's 2 of them given in the formula. So what does copper need to be to balance out those 2? 2, right, +2. So that means that this is copper 2 hydroxide. All right, so keep working on this. There's plenty of practice in the book. Online, if you look up naming ionic compounds or writing ionic formulas, there's lots and lots of practice there. Come see me if you're still having trouble with it. We will talk about it more next week, and we'll have our quiz on Thursday. All right. Thanks, everybody. See you Tuesday. What?
We have exams on 15 or something.
Oh, do we already? Wow, that came up fast.
Exam on February 15.
So that's. Oh yeah. Okay. So the exam will be on Wednesday. Wow, that's okay. That's different from last test. But that's fine. The exam will be on Wednesday. This will not be on the exam.
Until which part?
Actually, well, I guess it has to be on the exam. Yeah, it's in that chapter. Let's see. Yeah, because it's in that chapter.
And Ionic.
I'd really like to be through the next lab before we do all this naming numbers. It's pretty tough. So I would say, let's do this. Let's stop the exam material at what we finished on Tuesday, when we built the formulas for the names. We'll do that on the exam, but not this naming for today. Okay? We will still have a quiz on this naming on Thursday, the day after the exam.
We will not have.
But we'll not have this part on the exam. Just through Tuesday. The stuff we finished at the end of Tuesday will be on the exam next week.
So until next Tuesday.
What? No, last Tuesday.
Last Tuesday.
Yeah. What we already completed, that's what will be on the exam.
There is so exam is.
The exam is Wednesday in lab time. During that time.
What do we should expect on the exam?
The exam, you should expect all of those objectives from the different chapters, from the different sections. The things on Blackboard, the numbered list of things that you should be able to do, that's what you can see on the exam. There are unit conversions, measurements, heat and energy stuff, atomic structure, neutrons, protons, electrons, and writing formulas from names from Tuesday.
We will have matching, multiply, and short answers.
Yep, everything. If you want to look, there is an exam from a couple years ago on Blackboard in the practice exams folder. That exam probably went a little further than we did this time because this exam was a little earlier, but it will be the same format, so you can see what it will look like.
And we will write similar last time.
No.
Similar to writing.
No, same structure, same types of questions, but the questions will all be different.
Because I am bad at writing.
Oh, like that? Yeah, so it will be about half and half. Half multiple choice, filling in the things,
Yeah.
and half math and writing
It's
stuff.
good, but writing is
Yeah, there won't be too much writing.
I still not get anything.
Okay,
I tried, but
so yeah, keep working on it.
I have a question. How you get I get something else and like the last one. I get